These are the solutions to 2024's A-Level Maths A22 module. This was a Mechanics and Stats and Applied Mathematics module. Okay, first thing is how we read it in front of the paper. 3 sig figs were the answers that are given to, and G, you can see there, is 9.8 meters per second squared. The first question says, two particles A and B of masses 3 kilograms and m kilograms respectively are moving in opposite directions along the same straight line so that the particles collide directly. Before the collision, the speeds of A and B are 8 meters per second and 5 meters per second respectively. After the collision, the direction of motion of each particle is reversed and the speed of each particle is 4 meters per second. Find the magnitude of the impulse exerted by B on A in the collision. Okay, I'm going to draw a diagram and this will help me for the first part and the second part. So my diagram is quite simply this. I've got my A and I've got my B. A was 3 kilograms. My B was m kilograms. And this is my before diagram. And A is moving this way at 8 meters per second. B is moving this way at 5 meters per second. After, what happens is both of their directions change. So you've got your A, still 3 kilograms. You've got your B, still m kilograms. The directions now, B is going to the right, and A, from my diagram, the way I've set it up, A is going to the left. Now, impulse for A, impulse N is equal to mv minus mu. So I'm going to assume the direction that it is going is, finish is going is positive. So I'm assuming going this way is positive. So that means my mass of A was 3, my final velocity was v, my mass of A originally was still 3, and my initial velocity then was 8, but in the other direction. So that's what we've got. Now, if you do it on your calculator, that is going to be 12 plus 24. That's going to be 36, and that's going to be Newton seconds. Okay, next part says find the value of m. So for B, the impulse is still the same, so it's still 36, and that equals mv minus mu. Now the final velocity of B was 4, so that's, and the mass was m. And let's just have a look, sorry. And the initial velocity was 5 in the other direction, so minus 5 in the other direction. So I'll say that's m times minus 5. So let's just tidy up as 36 is equal to 4m plus 5m. 36 is equal to 9m. M works out to be 36 divided by 9. M works out to be 4 kilograms. Okay, Tom and Jerry are competitive sprinters. Tom is running along a straight horizontal road at a constant speed of 8 meters per second. Jerry is stationary at a point on the road until Tom passes him. Jerry immediately runs after Tom until he catches up with him. The time, t seconds, is measured from the moment when Tom passes Jerry on the road. Jerry's acceleration A is given by this thing. Show that Jerry's speed is given by this. So all of this, to be honest, we can ignore for a second. Let's just look at this. So you've got variable acceleration. So we're going to look at from 0 to 3, the first 3 seconds. And my v is going to be equal to the integral of my A with respect to time. So v is going to be equal to the integral of 6 minus 2t integrated with respect to time. And if you integrate that, you're going to get 6t minus t squared plus my constant of integration. Okay, how do I find my constant of integration? Now we've got to read the question. This was all about Jerry. So Jerry is stationary at the point. So he's at the time t equals 0, v equals 0, therefore 0 equals 0 minus 0 plus c, so therefore your c equals 0. So write that in, then your v is equal to, and it's going to be, it's going to be 6t minus t squared. That's for the first 3 seconds, remember. Okay, and then when t is equal to 3, let's find out what the speed is. So when t equals 3, v equals 6 times 3 minus 3 squared. And if you did that out, you're going to get your v is equal to 9. And what happens at t equals 3? T equals 3, a is equal to 0. So what happens is it starts accelerating. So once it gets up to that speed of whatever I've just said, 9 I think it was. Once I get up to that speed of 9, it stops accelerating. So that means you can then, the speed will just stop, keep going. So we'll just say at t is equal to 3, it stops, I think that's Jerry, stops accelerating. So v equals 3, equals 9, sorry. V equals 9, and that's for t is greater than 3. So that means your function v, remember it changes, 6t minus t squared, that's what it was for the first 3 seconds. And then it changes after 3 seconds, it stays at a constant speed of 9. Next one says, find how far Jerry has run when t is equal to 3. They're really leading you through this question. So to get your s, what you do is you integrate your v, and your v was 6t minus t squared dt, and your s works out to be 3t squared minus t cubed over 3 plus c. And you're told it's when s equals 0, when t equals 0, s is equal to 0, and a wee bit more working out, that means your c is equal to 0. So your s just equals 3t squared minus t cubed over 3. And then what do we have to do is find how far he runs when t equals 3. So t equals 3, s then equal to 3 times 3 squared minus 3 cubed all over 3, which means your s works out to be 27 minus 9. So s works out to be 18 meters. So Jerry has run 18 meters when by the time t is equal to 3. Okay, next one says find the time taken for Jerry to catch up with Tom. So find the time taken for Jerry to catch up with Tom. So we want to find where they are at t is equal to 3. So when t is equal to 3, Jerry, we have just worked out, has gone 18 meters. So when t is equal to 3, Tom has gone. Now if you go back, look back to the start of this, it told you that Tom was going at a constant speed of 8 meters per second. So in 3 seconds he's gone 8 times 3, he's gone 24 meters. So that means Jerry then is behind. Okay, so just to set this up. So find the time taken for Jerry to catch up with Tom. Right, so we know how far they've gone after 3 seconds, and clearly they're not, so Jerry's behind. We're now going to look at after 3 seconds, and you probably get nothing for this wee mark that this wee line that I'm going to do, but it really keeps me writing these questions. So what I'm going to say is let them meet t seconds after, and that's 3 seconds. So t seconds after the 3 seconds. So we're knowing this. There's a difference between their distances. So Jerry is playing catch up here. So and that one, and also just say and Tom has gone big S meters. And then Jerry, he has to go that as well. Jerry has gone the same. He's gone the S meters, but he also has got to catch up this difference between them. So he's also got to catch that up. So the difference between them is 6. So he's actually gone the S meters plus an extra 6 meters. So S plus 6 meters. Okay. Now we're going to set up distance equations. So we've got our Tom and we've got our Jerry. So for Tom, the distance Tom goes is big S. His speed, constant speed was 8, and the time is big T. So then you can just say distance, S, is equal to speed times time. So that's what you've got. You've got that for Tom. We want to do the same for Jerry. And although it's not going to be as easy for Jerry, is it? Slightly different. For Jerry, the distance is big S plus 6 we've just worked out. His speed, he is constant speed as well. That is pretty easy. So he goes, remember Jerry, once he gets up to a certain speed, where are we? He goes, this was Jerry, once he gets up to 3 seconds, he's just going at a constant speed of 9. That's right, forgot about that. So his constant speed then was 9. So, and the time that he goes for is the same as for Tom, it's t. So that means distance, s plus 6 in this case, is speed 9 times t. And then that means you can rearrange that to make big S equals 9t minus 6. Put that in a box. Put those two things equal. I'll squeeze this in here that we can see it. That's very easy. Bring the 6 across. Bring the 8t across. You'll have 9t minus 8t. So big T is equal to 6. Okay. Read the question. Find the time taken for Jerry to catch up with Tom. So it was 6 seconds, but your answer then, the answer is going to be 6 plus, remember the original 3, so it's going to be 9 seconds for Jerry to catch up with Tom. Okay, we are on to question 3. Lovely question here. Question 3 says a uniform ladder of length 4 meters and mass 20 kilograms has one end A resting on a rough horizontal ground and the other end B resting on a smooth vertical wall. The ladder is inclined at alpha degrees to the horizontal, and where sine alpha is equal to 4 or 5, a very useful way of seeing this. If you're going in doing this exam soon, folks, an exam like this, you really need to understand what I'm going to be doing with this. Very, very important. Coefficient of friction between a ladder and the ground is mu, don't know it. A man of mass 80 kilograms stands on a ladder at C, where AC is equal to 2.5, and the ladder is on the point of slipping. Okay, on the point of slipping means, first of all, your friction is equal to mu r. Okay, so friction's acting at its maximum if we're on the point of slipping. Okay, it says draw the force diagram. Hopefully I've underlined all the key bits here. We've got our, that's your wall. It's inclined, the ladder is inclined at alpha. You've got a normal reaction and do R here. And if this thing was going to slip, if his ladder was going to slip, it would go this way, which means friction must go against that. So instead of doing F, write mu R. We also have got a smooth wall, and this is coming out perpendicular to the wall. I'm going to call that big S. And by my angles, alternate angles, that angle is also going to be alpha. And then let's put, it's a uniform ladder. I think the mass of the ladder is 20. So I've got 20g going down here, 20g newtons. This wee dashed line is perpendicular to my ladder. That's alpha. And then we also have got a man climbing this ladder. He was 80 kilograms. And that's alpha. And what else do we know? We know this distance is 2. This distance was 0.5. So there's my A and there's my B. So that was my point C. And then this wee distance here would then be 1.5 meters. I don't know if they will need it. And what else we know is we're told that sine of alpha is equal to 4 over 5. Let's just do a diagram. I'll zoom in on this. There's your sine of alpha. So sine is equal to opposite. That's 4 over 5. And then by Pythagoras, and that's an easy one. If we don't know that, Pythagorean triple, we're in big trouble. We've got 3, 4, 5 triangle. If you didn't know that, you would have to work it out by Pythagoras. And also, in a different type of question, that might not work out as, it might not be a Pythagorean triple. If it works out to be root 17 or whatever, leave it as root 17. Okay, but ours works out nicely. And from that, then you can get that cos alpha. Cos is equal to adjacent over hypotenuse, so 3 over 5. So you've got exact values for sine alpha and exact values for cos alpha. If they set the question up this way, they want you to do it using these things. Now what we've got to do is find the value of mu. Now the 3 things that you can do here, you can resolve vertically, you can resolve horizontally, and then you can take moments about a point or whatever point it happens to be. But that's all you can do. So if you look at this question and you think, I haven't a clue, you can still get started and you will get an awful lot of marks for doing this. And then hopefully something sparks in and you know where to go. But there's no excuse to not get started in a question like this. Resolve vertically first of all. You will have 100G going downwards, and the only thing going upwards is R. So straight away, you've got your R is equal to 100 times 9.8, so 980. Okay, a couple of marks for that probably. Resolve horizontally, and you've got your big S going to the right is equal to mu R, and I'll just write then big S is equal to 980 times mu. There's another thing we've almost got. We need to find our mu. Well, need to find our mu. And then the last thing I'll do, and bear with me, I'll get myself a wee bit more space here. The last thing we can do is take moments. So here, I'm going to take moments about my point A. Now, the reason I'm taking moments about A is that means if I take moments about A, I can ignore this force, which acts through A, and I can ignore this force, which acts through A. Okay, and had the question just, say the question had given me alpha, and it wanted me to find S, I could have done it directly by just taking moments about A, but that's not the order in which they'd asked it or the way they'd asked it this time, so couldn't have done that. But what I'm going to do is clockwise is equal to anti-clockwise. Clockwise are the forces going this direction, anti-clockwise are the forces going this direction. So we'll do our clockwise first. So clockwise, there is one force. Oh, here, forgot to mark this on the diagram. This will make life a lot easier. You can see I've just added on a wee line. This line is going at right angles to my ladder. So going clockwise, I've got one force, and it's this one, this S force going in this direction. Okay, so clockwise, that was S. I need to get it through this angle to get it in the way I want it to be. So it's S. Don't have the angle, use sine. So S sine alpha, and its distance was 4 away. And that equals, so my anti-clockwise, I have two anti-clockwise forces. This one in blue going this way. So let's zoom in on that one. That would be 20G goes through the angle, so 20G cos alpha times 2. Let's just write that in. 20G cos alpha, and that was times 2. And then this one in this, I don't know what colour this is, this horrible sort of pinky purple colour. Going this way, so that's zooming in this one, that was 80G times cos alpha and then times 2.5. Let's just write that in, plus, what was that, what I just said? 80G cos alpha times 2.5. And then if we fire in all the values that we know, this thing then, S, remember, was 980 mu. That's what we're trying to find, the mu. And then that's times 4 times the sine, which is 4 over 5. And that's equal to 20 times 9.8 times my cos, which is 3 over 5, times 2. And then plus my 80 times 9.8 times cos, which was 3 over 5, and then times 2.5, and then we'll just work that out. The left-hand side of that, can I just check that? I've got a nice answer here, so I'm guessing it's right. 980 times 4 over 5, yep. I got 3,136 mu. On the right-hand side, when I work that out, 20 times 9.8 times 3 over 5 times 2, and then plus 80 times 9.8 times 3 over 5 times 2.5, I got, yep, 1411.2. So that's consistent with what I had written down. So that means my mu is equal to 1411.2 divided by 3136. My mu worked out to be 9 over 20. If you don't like that, write it as a decimal. It's 0.45. But the takeaway from this is the following. You've got 3 things you can do. resolve vertically, resolve horizontally, take moments. Absolutely no excuse for not starting that. Sometimes all you need to do, quite often all you need to do in these questions is take moments about the part at the point A, the bottom of your ladder. Okay, this one, I would imagine this is in most people's notes. Certainly it was in our notes. So it says a ball is projected at an angle theta above the horizontal with initial velocity of u. Prove that the greatest height h of the ball above the horizontal is given by this thing. Okay, so the greatest height, these are things I would never learn. I've just said they're in our notes, but I would never have learned them, to be honest. I would just work through. You have to work through it anyway. So the ball is projected at an angle of theta above the horizontal. So let's just do a diagram. There's your horizontal. There's theta. It's going off at mu, and it's going up that way. So it's equal to mu sine theta. At maximum height, your v is 0. Your acceleration, if you fire something up in the air, fire a ball up in the air, whatever it is, it doesn't have any boosters on it. It has no rockets, so it's completely reliant on gravity. It's moving under the action of gravity, you would say. So it's S then. So G is N. That's why your acceleration is just equal to this. Your S, so these things are all going vertically upwards. Ouch, that's an upwards arrow, just pointing at it there. It's upwards arrow. And my height upwards we've called H. So I'm just going to use V squared equals U squared plus 2AS. That's going to be 0 then. It's equal to square the U. You'll get U squared sine squared theta. And then plus 2 times my G, which is minus A, times my H. Bring that thing here across. You're going to have 2GH is equal to U squared sine squared theta. And then your H just equals U squared sine squared theta all over 2G. Is that what we're looking for? It was indeed. Lovely. Okay. Next one says a tennis player is playing tennis on an indoor court. The height of the ceiling above the floor is 9 meters. The player hits a ball with a speed of 25 into the air from height of 1. Find the greatest angle of projection with which he can hit the ball if he wants to ensure it never hits the ceiling. Okay, right. First of all, he hits it from 1 meter above the ground, so 9 minus 8 is 8 meters he's got to play with, really. So, and we want the greatest height to be less than 8. That's what we're looking for really in this. So your U is equal to the speed then. It's 25 above the horizontal. There hits a ball with a speed of 25 meters per second into the air. So it's the greatest, that's the angle. So he's fired the ball off like this. 25, and we want to we need to find the angle he's going above. So remember, it was u sine the initial speed times the sine theta. Okay, and then we want, remember the formula was u squared sine squared theta over 2g, and it has to be less than 8. That was what your maximum height was. So that top line is this thing squared then, so it's going to be 25 squared sine squared theta all over 2g is less than 8. And then that means our sine squared theta has to be less than, and that's just going to be 8 times 2 times the g, and all divided by the 25 squared. So a wee bit of working out, that means your sine squared theta has to be less than 0.25088. We'll ignore the negative one, and we'll just say that means sine theta has to be less than 0.500875 when you square root that. And then that means when you do sine to the minus 1, I got 30.1 degrees to 3 sig fig. So it's an awkward enough wee question. I have to say I found that a wee bit tricky, this wee bit up here. I nearly would prefer doing that one from scratch without thinking about the formula. There we go. They sort of wanted you to use the formula. Okay, it says another player hits a ball from a height 2 meters above the court at an angle of 5 degrees below the horizontal. The initial speed of the ball is 40. Find the time taken to hit the floor. Okay, sort of different question here. Right, 5 degrees below the horizontal, there's my diagram, and the speed was 40 meters per second, and the distance to the ground, then distance from the ground, that was a height of 2 meters. So I'm just going to use go vertically. So my u is initially it's 40 sine 5. My acceleration is 9, so that's downwards. My acceleration is 9.8 downwards. My distance is 2, and we just want to find the time. So you're just going to use S is equal to ut plus a half at squared. So just fill that in. 2 then is equal to 40 sine 5 times your t, and a half times the 9.8 will be 4.9. That's t squared. So it's a quadratic equation. You can use your calculators to do that, or use, as I would do, just use the formula. So I would say then that's 4.9. Sorry, bring it all to one side first of all. What am I doing? 4.9 t squared minus, or sorry, plus, and that worked out as 3.48623 t, and then minus 2. And again, you can use your calculator to do that, or you can do the formula as I will do here. Minus 3.8623 plus or minus 3.48623 squared minus 4 times my a, which was 4.9, times my c, which was minus 2, square root of that bit, all divided by 2a, so that's 2 times 4.9. And the answers I got were t is equal to minus 1.09, that was the 3 sig figs, or t is equal to 0.376 seconds, again the 3 sig figs. So that is the answer we're looking for. So just ignore that one. That is our answer. But just don't score it out, but just write ignore. And that's us. Okay, question 5. Where are we? Okay, question 5. I and j are unit vectors in the directions of east and north respectively. The velocity v of a particle p at a time t is given by this thing. Find an expression for the acceleration. So to get your acceleration, you differentiate. So you do your dv by dt. And if you differentiate that, differentiate the I part, differentiate the j, differentiate the i's, you'll get minus 2i. Differentiate the j, you just get minus 7j. That's it done. That's pretty nice. Okay, it says when t equals 0, the particle is passing through a point which has a displacement. So that's your initial displacement is this. Find an expression for the displacement of p from O at a time t. Okay, so now what we've got to do to get your s, you've got to integrate your v with respect to t. So we're going to integrate the two bits. So if you integrate, there's your v. Integrate this bit, you'll get 8t minus t cubed over 3. Integrate this bit, you'll get 18t minus t squared over 2. 7t squared over 2. So that's going to be, let's just write that in, 8t minus t cubed over 3 I plus 18t minus 7t squared over 2 j plus, and this is a vector constant here, because there could well be I bits and j bits, we will soon see. Right, now we're using this bit of information. So when t equals 0, s was 2i plus j. So let's just put that in. So that means 2i plus j then is equal to, that's going to be 0, that's going to be 0. So 2i plus j just equals your c. And that means therefore your s is equal to 8t minus t cubed over 3 plus 2, that's the i's, plus 18t minus 7t squared over 2, and then plus 1, and that's your j's. So you've got your s equation. Okay, right, the next question says, find the time at which the particle is traveling on a bearing of 0, 5, 0. A lot of people telling me this was an impossible question, all this here. Absolutely not. Bearing of 45 degrees means this. So bearings are measured from the north they're measured clockwise, so that means the angle you've gone through is 45 degrees, and there's 3 figures before them, but that's all it's doing, so it's moving in this direction. So if it's moving at 45 degrees from the vertical, it's 45 degrees from the horizontal. So it's moving at a gradient of 45 degrees, or sorry, a gradient at 1. So a gradient of 1, so if u equals y equals x, that's the most famous line with gradient 1. That's what it is. Gradient 1 means that, if you think about that, it means your rise and your run, your vertical change and your horizontal change are the same. So that means like it would be 1 over 1, or it would be 2 over 2, or it would be 100 over 100. But whatever it is, the vertical change and the horizontal change are the same. So we need to go back to the start, and they gave you the V, and put your vertical change and your horizontal change. It's two things, sorry, that did them the wrong way around. The horizontal change and your vertical change, we're going to put them equal because it's to do with velocity. So I'm just going to write that up. So this is not, I wouldn't write this in an exam, to be honest. I would just do it. But if going at, whoops, was it 45 degrees, then horizontal change, or I'll write down horizontal component of the velocity equals the vertical component of velocity. Okay, so that means, what were my things? There a minute. I'm clicking back on the book here to look at this. The horizontal component was 8 minus t squared, and the vertical bit, the j part, was 18 minus 7t. Let me just write that down here. 8 minus t squared is equal to 18 minus 7t. And then we'll just sort that out. Bring it all to one side, put it equal to 0 of 8t squared minus 7t plus 10. Oh, look at that. That factorizes really nicely. T minus 2, t minus 5. So t is equal to 2, or t is equal to 5. Okay, now, if you go back to the question, there's my velocities. There's my velocity. One of these may not work, so we're going to have to put this in. So put these in and find out. So I'm running out of space here now. So when t is equal to 2, my v would have been 8 minus 4 I plus 18 minus 14 j, and that equals 4I plus 4j. So you can see that one works. So that was my find the time. My answer then is going to be t equals 2. Just to show you, when t is equal to 5, your v would be equal to 8 minus, and it would be 25 I plus 18 minus 35 j, which would work out to be minus 17 I, minus 17 I minus 17 j. So it is on that 45 degree line, but it's actually going this direction. Okay, so that's not the one we're looking for, because it's on the 45 degree line. That's as good as the mathematics can go, but you've got to interpret it. So my answer then is t is equal to 2 seconds. Okay, that's what we're looking for. All right, so this one here, the one on the left, this one, it is going at your 45 degrees there if you do it. So that's why we're looking at that one. So trick enough wee question. There we go. Okay, hence find the speed of the particle p at this time. Okay, we have worked out when t is equal to 2, your velocity is equal to 4I plus 4j. So the speed then is just going to be 4 squared plus 4 squared, square rooted then. That's going to be root of 32, which is 4 root 2, which is perfect. And I haven't written that in. It's 3 sig figs, I really should. Square root of 32. So hopefully they probably want this, but 5.66 meters per second as well to 3 sig figs. Okay, on to section B, the statistics part of it. Okay, it says in this question, A researcher is testing whether the product moment correlation coefficient of a bivariate population is positive. For a random sample of 12, he calculates that R is equal to 0.516 and the size to use a 5% significant level. Write down the critical values for a one-tailed test. So this is from the tables. I got this. So these are the tables you're looking at here. So there's 5% and 12. So you go across and down from this. And what you get is this one. So 0.4973. So my critical value then, so it was 1%. So, it was 5% and it was one-tailed. So my critical value then is 0.4973. So I don't think there's any calculators out there that can find the critical values for the product moment correlation coefficient of that on that sort of thing. So we've got to use our table still for that. Okay, based on this value, what conclusion can the researcher draw? So our critical value was this. So if you get bigger than this, then that means it is in the critical region, which means you would reject your H0, and your H0 is at the default, and then you would accept your H1, and H1 is what you're trying to prove. And if you look at our value, which I'd highlighted up above there, was 0.516. It is greater than the critical value, which means there is evidence at 5% level that there is positive correlation. So it's let's go through that again, right? They were talking here in this one. This was whether or not the product moment correlation coefficient. So product moment correlation coefficient is whether or not there's a relationship between two variables. So you have three situations. You've got your R equals 0, and that's where there's absolutely no correlation. Your R is less than 0. That means there's a negative correlation. So I don't know what the negative correlation thing would be. So maybe as time increases, the value of something decreases maybe. And then positive correlation. So as one thing gets bigger, so does the other thing. That's all it is. So we have shown that there is evidence at 5% level that there's positive correlation. So that's what we're at here in this question. Okay, next one, question 7. It says, independent events A and B are such that probability of A is equal to 0.3, probability of B is equal to 0.65. Write down the value of probability of not A given B. Okay, first of all, the probability of not A is 1 minus 0.3. So the probability of not A is equal to 0.7. Now, they are independent events. So that means A or B happening has no impact on the other one happening. So that means probability of not A given B just equals the probability of not A. So it is just equal to 0.7. So that's what we've worked out. Probability of not A given B just equals 0.7. All right, so B happening or not happening has no impact on A not happening. Next one we want to find is probability of A union B. I will just write down the formula for it. It is A, probability of A plus probability of B minus the probability of A and B. But because it is independent, there was your probability of A, there was your probability of B, and this thing here is the same as your probability of A times your probability of B. So just work that out and see what you get. And when I worked that out, I got 0.755. Hopefully that is correct. Okay. The next bit then says events X and Y. Okay, so it's a different setup. Events X and Y are such that the probability of X is equal to 0.3 and probability of Y happening given X happens is 0.4 and Y not happening given X not happens is 0.8. Using a tree diagram or otherwise, calculate probability of Y. Okay, right. Okay, you've got X or you've got not X. Then after that, you've got your Y or you've got not Y. You've got your Y or you've got your not Y. So that's what you can have. The probability of x is 0.3. That means the probability of not x is 0.7. That's all we can do there. And then the probability of y given x is 0.4. So that's this wee branch, single branch up here. Then we'll look at this one. Probability of not y given not x is 0.8. So that's what's happening here. So then you can fill in the rest. If that one was 0.4, the next one's 0.6. If the bottom one's 0.8, the one above it is 0.2. And then what we want to find is probability of y. So let's just highlight it. This branch here. So probability of y is 0.3 times 0.4 plus 0.7 times 0.2. Doing this without a calculator here, that's 0.12 plus 0.14, which is 0.26. That's quite nice. 0.26. Okay, now the next bit says to find the probability of not x given not y. This was a wee formula. This is our conditional probability formula. We formula I found very difficult to learn or to get people to learn, I should say, for a large time. But if you look here, that's what your formula is. Understanding the formula is important then. So it looks like this. You've got a slash b. That's a bit like a is being divided by b. And what's on the bottom line is a b. So as if the b is dividing here. So same idea here. You've probability not x given not y then. So that's going to be the probability of not x and not y. And then it looks like the not y is dividing. So probability of not y goes on the bottom line as well. And then you're good to go. Fill that in. So bottom not x, not y from our tree diagram was this bottom line, bottom branch I should say. So 0.7 times 0.8. So 0.7 times 0.8. And probability of y, not y, we worked out in the last question was 0.26. So not y will be 1 minus 0.26. Do that in one go on your calculator. I got 28 over 36. Let me just check that, sorry. 0.7 times 0.8. And then divided by 1 minus 0.26. Identity 28 over 37. Press SD, 3 sig figs, 0.757 to 3 sig figs. Okay, where do we get to? Okay, next one says, a machine cuts lengths of woods for the use of as shelves on a bookcase. The lengths of wood are normally distributed with a mean mu and a standard deviation of 0.4. So that's how it's set out. It says, given that 20.5% of the lengths of woods are longer, so probability x is greater than, longer than this, sorry, 90.324. That equals 20.9, so that's 0.290 when we want to find the value of mu. Okay, so there's your 90.324 here, and this is 0.209. That means the probability that x is less than 90.324 would be 0.791 then. All right. Now, because we don't have the mu, we can't just use our inverse normal straight away. So we've got to change it and find the probability that z is less than z1. So there's a z1 which corresponds to a real life value, real world value of 90.324. Okay, so we've got to use our inverse normal mode on our calculator. So inverse normal mode. You could also go to your tables. I'll maybe do another video at another stage, but I really advise that using the class whiz calculators to do this. Your area then was, area you put in is 0.791. And if it's normal tables and z is, z is distributed with a mean 0 and a sigma 1. So my sigma is equal to 1, my mu is equal to 0. When I put that in, I got z1 to be, I've used a whole pile of decimal places, 0.809896. And then we use our conversion formula, Z equals X minus mu all over sigma. And then we put in what we knew. So that was our Z1 value was 0.809896. Our X was 90.324 minus mu all over sigma, which is 0.4. Now it's a wee bit of rearranging just to get your mu. That's all we're doing now. So here, if you do that, so that's going to be 0.4 times the 0.809896 is equal to 90.324 minus mu. Bring that mu across the other side, it becomes positive. Fire the other thing across, it becomes negative. And fire that into your calculator, and I got 90.0000416. So the 3 sig figs, 90.0. So going forward in this question, I'll be using 90 as my mu basically. Okay, next question says a length of wood is selected at random. Find the probability that the length of this piece of wood is between 89.9 and 90.2. So I've just written this down so I wouldn't have to go back and forward. So what we're looking for in this question is the probability that X is between this, and you can do this directly on our calculator. So that's what we're looking for. So you're using normal CD mode. So you go into normal CD and then you go your lower value. You've got your upper value. You've got your sigma and you've got your mu. So your lower value is 89.9. That's where that came from. Your upper value is 90.2. That's where that came from. Your sigma is up here. It was 0.4 and your mu was 90. And then hit that into your calculator. And that gives you the probability 89.9 is less than X is less than the 90.2 was equal to 0.290 to 3 sig figs. Okay, I thought that should have been done on this question. I kept going with this one. Okay, it says to be used as a shelf, wood must be longer than 89.5 centimeters. 2 lengths of woods are selected at random. Calculate the probability that neither length of wood can be used for the shelf. Okay, so I need to find the probability that 1 is not used. So that's a probability that X is less than 89.5. So again, it's normal CD mode. And I got my lower, my upper, my sigma, and my mu. So my mu was 90, my sigma was 0.4. Okay, my upper is easy to see. My upper is 89.5 because it's got to be less than that. My lower is minus infinity, really. But what you could do here is, the way I do it is minus 9 times 10 to the power of 99. If you don't like that, do the following. Just do put in minus 1 million or whatever, the biggest number that's able it lets you do. And you should get the same thing, roughly anyway, when you do it a few decimal places. So when I hit that into my calculator, I got probability X is less than 89.5. I got 0.10564977737. Okay, that was a probability of 1. We wanted the probability that both can't be used. So we're assuming, and this will be the next answer, we're assuming they're independent. So probability both not used is going to be that probability that I've just written down times itself again, or else you could just write that probability squared. Okay, so then that's 0.0112 to 3 sig figs. Okay, and the last bit of that one, what was the assumption that you made? You're assuming they're independent values. Okay. Right, let's see. It says, over time, the manager of an electrical goods store notices that 20% of customers who buy a DVD player return it. Following a sales promotion, the manager suspects the probability of a DVD player being returned has increased. He decides to test his suspicion. He tests a random sample of 10 DVD players which were sold following the promotion and finds 3 of these were returned. State the null and alternative hypothesis. So this is EDEXCEL. It's a binomial, 10 and 0.2. The probability of being returned is 0.2, something being returned is 0.2. And he thinks it has increased. So that's why it's going to be a p is greater than. So the initial probability that we're trying to assume, prove has changed, was 0.2. And he thinks there's more than 20% of people are returning them. So that's where we're getting all of that. So that's all it is. Okay. It says, explain the meaning of the term critical region. So the critical region is a region that the test statistic must fall into so that you would reject H0 in favour of 1. So say your critical region was 5%. So the top 5%, so if it fell into here, so that was 0.05, whatever my value, if it fell into here, then I would reject. So if it fell here, then I wouldn't reject my H0. So if it goes into the right-hand side, one in yellow here, you would reject. If it goes in here, you wouldn't reject. That's basically it. Okay, right. Find a critical region for a 5% level of significance. So what we need to do here, our x was distributed, it was binomial, 10 and 0.2, and we need to find the probability that we want to get this as close to 5% as possible. So that's why we want this region to be 0.05. Now, binomial CD works with a less than or equal to. So really I want this to be 0.95 up here. So we're going to try use binomial CD. I'm going to put x equals 3. My n is from up here is 10 and this is 0.2. And I'm just trying a wee bit of trial and error here. So probability x is less than or equal to 3 worked out to be 0.879. That means probability that x is greater than or equal to 4 would be equal to 1 minus that, which would be 0.121. Okay, so that's 12%. That's not going to be working for us. So then I tried again. I did x equals 4 and then 10 and 0.2. And I got the probability that x is less than or equal to 4. And that was 0.967. Therefore, the probability that x is greater or equal to 5 then is 1 minus that thing above, which is 0.033. And that is 3.3%, but I'm just going to say that's less than 0.05, which is what we want. So the critical region is x is greater than or equal to 5. So if I get 5 or more things returned, basically, then I will reject. Okay, next part says, wherever it is, complete the hypothesis test, interpreting the result conclusion, interpreting your conclusion in context. Okay, there were 3 returned. So I've just said there are 3 returned. So that does not fall into the critical region. So remember our critical region, wherever it was, our critical region was x is greater than or equal to 5. So 3 returned is not enough. So 3 returned, 3 does not fall into the critical region. So insufficient evidence to reject H0, i.e. insufficient evidence to suggest that the probability of a DVD player being returned has increased. You need, I think there's a 3-mark question. You would need to say, does not fall into the critical region. I'd imagine you need to say 3 bits this, wherever the last bit would be, well, the second bit. Insufficient evidence to reject that. And then you need to also do the real life thing, because it mentions that in context. And then I think maybe saying that it doesn't fall into the critical region, something I'm not too sure where the 3rd mark comes from. The second 2 are more obvious. Right. Last question, is it? I think it is. Right. It says the length of time Tom takes to travel to work is normally distributed with a mean of 35 minutes and standard deviation. So let me just write down how x is distributed. Mean of 35 and a standard deviation of 3.1, so 3.1 squared. And over a period of time, there were roadworks in Tom's journey. Tom claims that roadworks significantly increased. So he's going to be saying H1 is mu is greater than. Increased his time to work for a random sample of 40. So my N is 40 on these days. He calculates his mean time to travel to work to be 36. So let's just write down N is equal to 40. Okay, that N equals 40 is very important. Your X bar then is distributed with a normal distribution, the same mean, but the standard deviation, or the variance now is sigma squared over 40. Okay, which means, I'll just write that here, when we're working with our formulas, our mean is 35, and sigma we're going to be using as 3.1 square root of, we're not going to be doing that at all. It's going to be 3.1 over the square root of 40. So when we come to using that, that's what we're going to be doing. Okay. Originally, the mean was 35, and Tom thinks it's increased because of the roadworks. So that's what he thinks it is. And it was so it's a one-tailed test at a 5% level. So what we're hoping to find is Tom is hoping that he's going to get his value falling in here, and then we can reject. We don't know. Okay, we'll have to work through this. So Tom finds that his time to travel to work is now 36. So let's work out the probability. The average time then is greater than 36. That's what we're looking for. So that was in 40 days. He worked that out. So we're going to use our normal CD again. My lower value is the 36. My upper value is infinity, really. Write that as 9 times 10 to the 99, that will do. And sigma is that thing up in red there we've got. So you put it in as 3.1 divided by the square root of 40. So just put that in your calculator, and your mu is 35. Now what I worked that out to be was that X bar, probably the X bar was greater than 36, was equal to 0.0207. So that's only 2.07%. So where would that be? It would be well in here. So it looks like he is correct. So it's in here. You can see where that would come in. It's in that thing. So we'll just write that up. So I've just said there we are to finish off. So probability X bar is greater than or equal to 36 was 0.0207, which is less than 0.05. That was 5%. So evidence at a 5% level to reject H0 and accept H1, i.e. evidence to suggest the roadworks have increased the journey time. So it looks like his assumption is correct. And that is the end of that exam.